All right, I am here to help if you have any questions. Type in the chat. I have 0 people watching right now, so. This. Log into code.org in case we have questions about that. Yeah. Let me know in the chat if you have any questions about anything at all. No. No barking. Which parts of the packet do you have questions on? Which questions? Let's take a look. So first thing of note, make sure you've done everything else. To earn a 3.5, you have to have everything before the 3.5 done. Oh, these are backwards. This should be a 3, and this should be a 3.5. Oh no, this is correct. They're backwards in order. This should be the first question, and this should be below it on the packet. But that's okay. No, everything is in the right place. Why must counter patterns be inside of draw loops to work? So here you're just answering a question about why a counter pattern, which is like sprite.x gets sprite.x plus 1. So using a counter pattern like that, why would this work inside of the draw loop and not outside the draw loop? So let's take a look at a block of code here as an example. Give it a second to load. Let's take a look at this. We should be able to investigate it here in lesson 15. Take a look at the original code. Yeah, so if we're using the counter pattern here, so let's keep it, I don't know, they don't give us, I'll just do it in text mode. So fish.x gets fish.x plus 1. If I put that outside of the draw loop here, nothing happens, right? The fish is not moving. If I move it into the draw loop, now the fish moves. So the question is really asking, what is this function draw doing? So why must counter patterns be inside of draw loops to work? Well, what does function draw do? It loops through the code and reads it over and over and over, right? We need that to happen for the counter pattern to work. Otherwise, it's not going to update. The draw loop, when you run the code, the draw loop runs continuously. The draw loop, anything inside the draw loop keeps running over and over and over and over, nonstop, forever and ever. It's an infinite loop. So if the counter pattern code is not in the draw loop, right, it's not being read by the code or by the computer. It's not reading this fish gets fish plus 1 over and over and over. It's not adding to the x value because it only reads the code once. We need it to read the code multiple times. We need it to read the code over and over and over for it to create what looks like movement. That's what this question is getting at. Why must counter patterns be inside of draw loops? Right? Just think about what the draw loop does, the purpose of the draw loop, and try to explain that. Should help you get to the answer. How a negative velocity would be similar to a counter pattern that uses subtraction. So if I did, I'll just kind of show you this one, and you can put it in your own words. So a counter pattern that uses subtraction. Let's move the fish over to the right so we can see this a little more clearly. Oh, that's not going to do anything. Let's do 350. So when we use subtraction with our counter pattern, whatever we subtract moves to the left, right? That's going to be similar to how a negative velocity works. So if I get rid of this counter pattern and I do fish.velocityx, it's going to do the same thing. In both cases, it's moving the fish, or the sprite, any sprite, it's going to move it to the left across the screen. And I got your email about the grades. I am updating grades today, actually, after this live stream is over. So around, in the next 10 or 15 minutes, I'm going to start putting grades in. And then I will, tomorrow I will check everyone's assignments one last time before submitting final grades for the quarter. What's similar as orange x minus 2? Where's the orange? Yeah, so that's kind of getting at the same thing that we were looking at just now, right? Using subtraction with a counter pattern is going to be the same thing as orange dot velocity x gets what number, right? Think about what number is going to go here. What's the value of velocity x going to be if we want it to be the same as subtracting 2 from the x position? The velocity is going to be negative 2. Specifically negative 2, right? Because when we're subtracting, it's going to move to the left across the screen. So if we want to make it move to the left using velocity, the velocity has to be negative. So number 8. So here we're in number 7, so the 8 is related to number 7. I didn't make that should have been 7A and 7B. I did throw this packet together quickly on that last Friday we had, so I do see how that's not clear. So 7 is asking if sprite gets sprite x plus 1, if that changes the x position while the code is running. So this should say, what will sprite velocity x get sprite velocity x plus 1 do? So if a counter pattern on the position changes the position, then the counter pattern on the velocity is going to change the velocity, right? So what's it going to look like if the velocity is changing? Think about that when you're answering question 8. Instead of it moving the same speed across the screen, actually it's going to move this way, right, with addition. Instead of it moving the same speed across the screen, what's going to happen? Well, if the velocity increases, it's going to look something like this. We could actually demonstrate that in the code. So let's put fish back at 50. So fish velocity x gets 1. Run the code, right? Here it's moving the same speed. What happens if I do velocity x gets fish dot velocity? Just to make this a little easier to see, I'm going to use a smaller number, a decimal. Let's watch what happens with the fish. So it starts off slow. No, it's not changing fast enough. Let's try that. So you can kind of see, I think it's lagging because my computer actually can't handle streaming while, yes, I'm looking at your answer now, that is correct. It is going to move faster. It's not happening right now with the fish because my computer is can't handle streaming and running the code at the same time. It's just too much on my computer, but that is correct. The speed is going to increase. It is going to move faster. All right, are there any other questions? I see I have 3 viewers, so if anybody has any questions, type them in the chat. To earn 3, yes. So here. So what we're doing in question 3 is we're just comparing and contrasting code that is inside and outside the draw loop. So let's look at an example here. Oh, I see why this counter pattern wasn't working. It wasn't in the draw loop. See? And now it speeds up. It wasn't working because it wasn't in the draw loop. I wasn't paying attention to what I was doing there. Yeah, so this should make it more obvious, the question 8, right? When you have a counter pattern applied to velocity, it makes the velocity speed up. It makes the sprite speed up. So in general, what's happening between, let's take a look at a new level here just to get a better look at. I think 5 is a bit simpler. Let's take a look at 9. Trying to find a good example for this. So the code outside the draw loop here is code that's not going to change, right? We don't need to change the animation. We don't need to change the sprite that we're making. But anything that needs to run in the loop, anything we want to change over time, or if we want the computer to be watching for these if statements, right? It's watching for if fish is less than 0. So anything inside the draw loop is code that we want to run over and over and over. If there's code, if there's properties we want to update, if there are conditionals we want the computer to read, those are two really big, those are the two big concepts of what needs to go in the draw loop. Code that goes in the draw loop is code that either needs to update or it's a conditional the computer needs to check for every time it runs through the loop. Code outside the draw loop is any property that is going to stay the same no matter what. It doesn't need to change as the program runs. I think that answers the question. Yeah, so those are the differences. The similarity is, I mean, you can kind of see just kind of looking at, you know, the code we have here. There's a lot of similar code that we can put outside the draw loop and inside the draw loop, right? We can set the animation outside the draw loop. We can also set the animation inside the draw loop. There's a similarity. All right, let's take a look at that. Compare the two blocks of code to get a 4, go step by step through each line of code and explain what is happening. You can do this with blocks of code where it applies, for example, line 7 and 8 to create a sprite and set its animation. So basically what you need to do here is, and there, I mean, it's a 4 for a reason, and honestly, if it's done well enough, it could probably be worth a 4.5. Because what you have to do here is you're going through each line, or if you see code kind of blocked together. So you see, like in this block, line 7 and 8 is a block, 11 through 14 is a block of code, 17 through 20 is a block of code, 23, 26, 29, 32 through 35, 38 through 40, 42 through 44. Go through each block of code and explain what it is doing. So you don't have to go line by line exactly, but block by block. Explain what each block is doing. And the reason that's it's a challenge question because that's why it's going to be worth a 4.5 or a 4. It's hard to do. I don't want to walk you through the answer on this one because if you're going to earn a 4 on it, you kind of need to be able to do it on your own. But I can give you some guidance here. Do 7 through 8, 11 through 14, 17 through 20, 23, 23, 29, 32 through 35, 38 through 40, and 42 through 44. So just to do the first one as an example, what is happening on lines 7 and 8 of the code? So I'm looking at blocks 7 through 8. All right, so what this line of code is doing, and this line of code is doing, is it's creating a sprite with the name character. So it creates a sprite with the label character. Specifically, it puts its location at 200, 200 on our grid. And it sets the animation of character to flyer. If you don't understand the Corona packet, it's okay. So the Corona packet is an enrichment. I'll type this answer out just to make sure it's clear. So it's only going to be used to replace a previous bad grade. If someone doesn't do the packet, it's not going to count against them. But letting it replace a previous bad grade is a really good way to help people bring their grades up. So that's why I wanted to do it that way. So anyway, with to earn a 4 here or even a 4.5, you're doing with each of these blocks of code, you're doing what I just did here, which is writing a short summary. What is that code doing? And if you can show me that you understand what each block of code is doing, that's a pretty deep knowledge of the content to understand all of this stuff. So I think that warrants a 4 or possibly 4.5 as a grade. I mean, I'd even go so far as to say anybody who can walk me through this code and explain what all of it is doing should certainly have a passing grade in my class. Because I know this is complicated stuff. Oh, my video feed is cut off. You're only seeing, is it? Or is that just my screen? Oh, that's just my screen. Never mind. We're good. Any other questions? It's about 1 o'clock here, so I'm about to wrap this up, but I will take any last minute questions before I get to As soon as I close out here, I'm going to start updating grades. You are welcome. And then I will update grades again tomorrow, and that will be it for the end of the third quarter grading. Alrighty, well, if that's all the questions, I'm going to go ahead and close up here. I'll be back on tomorrow around the same time to go over any last minute stuff for the end of the third quarter. Alrighty.